Thank you to the student who sent this question in. It's an important question in a number of courses, but especially in pre-calculus algebra, because when we simplify this expression, what we're simplifying is something that could be used as part of the quadratic formula. So when we go to solve a quadratic equation, you'll sometimes use a quadratic formula and get something that looks like this. It's in this form. But then it's important that you're able to simplify it. So in this video, I'll walk you through how to go about simplifying this. I'm going to apply the order of operations. So I'm going to take care of anything in a grouping symbol. So that means I've got to start with what's inside this radical first. So I'm looking at the opposite of 6 squared minus 4 times 1 times 3. So let's start with that opposite of 6 squared. You want to notice that the negative is inside these parentheses. So this means negative 6 times negative 6, which will be positive 36. And then subtract 4 times 1 times 3. 4 times 1 is 4. 4 times 3 is 12. So we get 36 minus 12, or 24. Let me insert that in. Here we have x equals the opposite of negative 6 plus or minus the square root of 24 all over 2 times 1. Now I could go ahead and do that 2 times 1 and get 2. I could go ahead and simplify this opposite of negative 6 to be positive 6. So we have 6 plus or minus the square root of 24 over 2. Now the only thing left to do here is going to be to simplify that square root of 24. And I think that that's often the part that students struggle with the most, because we have to review working with radicals, and in this case it's a square root. So we're looking for any number that we could pull out of that square root of 24. If I rewrite the 24 as a product of prime numbers, and I could do that by making a factor tree, right? So 24 is equivalent to 2 times 12. There's a prime number. 12 is 3 times 4. 3 is a prime number. 4 is 2 times 2. So I have 2 times 2 times 2 times 3. There's an implied index of 2 in the square root. We don't usually write that in there. It's just implied that if there's not an index, then we know that it's 2. We know that it's a square root. And so because it's a 2, because it's a square root, let me write that in here. So I'm talking about this green 2, not this pink 2, right? But because this index is 2, means that whenever we get 2 of a kind, it could be removed from that radical. So we see that that's why the square root of 24 is equivalent to 2 times the square root of 6. So this 2 times 3 stays in the radical, in the square root. But the 2 times 2, the square root of 4, in other words, square root of 4 is 2. And that's where this 2 comes from. So let's take that over to our expression. And we have a 6 plus or minus 2 square root of 6 all over 2. Now here's where I'm never sure from one student to the next what is going to make the most sense, because I'll tell you what we're going to do. We're going to reduce the 6 and the 2 by this 2. But notice when I said that, I said we're going to reduce the 6 and the 2. What we're doing here is saying that this is equivalent to 6 over 2 plus or minus 2 square root of 6 over 2. And so when I reduce, this 6 divides by 2, 6 divided by 2 is 3. 2 divided by 2 is 1. So the 6 divided by 2 is just 3. And then the 2 divides out the 2. So we have 3 plus or minus the square root of 6. And 6 what's left. And that's it. That's the final simplified version of this expression. So I hope that that makes sense, and whatever piece you had a question about, I hope that answers your question and makes it crystal clear. But if you do still have a question about this or other problems like it, please let me know, because maybe in making this video, I've overlooked what question you had about it. Thanks for making time to do this work, and let me know if you have any further questions.